Okay, Assalamualaikum and very good morning.
Waalaikumsalam, Doktor.
Okay, class. Today we continue the questions that I have shown you, and I think this question saya pun dah bagi dah. So kita cuba selesaikanlah. Okay. So what we have been discussing in our previous class. So this is the bevel pinions. Bevel pinion, the pinions. Smaller, normally pinion is the smallest gears, mating with the largest gear. So because of bevel because it has the certain angles. And then it has a shaft, okay? So it has shaft, and the shaft supported with bearing A and B, and one end is free and one is attached, coupled with electric motor. And the load component applied by the mating bevel gears as shown. Okay, so the other, actually the radials, tangents, and axials forces. Okay, so first kali kita kena get the reaction force. Macam mana? So by looking at this the figures, we could assume that we could plan how to calculate the reaction force by having two planes. Okay, one plane is this plane. Okay, this plane. Okay. So from this plane yang kita lihat from this side. So from this plane kita akan lihat this forces. Another plane yang kita lihat ialah this plane. Okay, where we see the plane from above. So we could see from two different angles, okay, different position of the planes. So from above, from the green plane, we could see this plane, these forces, and these forces. Right. So free body diagram for the green plane, for the red plane, free body diagram. Kita buat, this is A. This is A. This is B. So kita akan dapat lihat, this is gears. Yeah. Oh, okay. I think the red one is different. The red one is different. Okay, the red one, tengok from different angle. Okay, this is the green angles. This is the green one. The green. The green. So for the green, kita akan dapat tengok ini. So, this one. Okay. For the red one, kita lihat this one different. Mudah kita lihat daripada depan. Kita lihat daripada depan. Okay, so if we see from this direction, we will see the forces is this force and this force. So this force and this force. So this 1.5 and this is 2.4. So for the green one, for the green colors, we could see from this one. Green colors from above we could see one is this is the point, this one, and the one is this direction. Okay, this A is the B. Then we could do the reaction force for A here. And another one reaction force, this one. Because this the forces and the reaction force here. Let's say this is, let's say we call it X, so Y. Different plane. Whatever you could call it plane one or plane two, plane X, plane Y. And for the red one, we have, because one, the forces towards downwards, so the reaction force is upward. And 1.5 is here, so this should be here. Okay, let's say we call it this as RAX. This RAX. This is RAX. Oh, Y. This is RBY. Quite confusing, eh? Quite confusing using X and Y. But the direction, so normally X, Y is the axis, but quite confusing when we use the X and Y. So kita pakai satu lah. Tu. This RB1. Itu RB. Okay, kemudian kita kira first. So once you have get how to look the forces acting on the component on the gears using the plane, I think if you get this correct, I think you will have no problem. Okay. Then selepas tu just normal calculation of getting the forces. So kita kira MA, let's say MA equal to 0. Zero, this is 75, this is 75. And this is 125, and this is 50, same as this is 125, this is 50. So moment daripada sini we will get this RB1. RB1. So RB1 in this direction, and 1.5 the same direction with RB1, and 2.4 is the opposite direction. So 2.4 times 125, the opposite direction is 1.5 times 75, then this RB1. Okay, plus RB1 times total 125 plus 50, 175. So you will get RB1 equal to 2.4 times 125 minus 1.5 times 75 divided by 175. Then you will get 1.07 kilonewton. This is the reaction force at B at this plane. So kemudian, the next one is RA1. So go to 0. So RA1 plus RB1 equal to 2.4. So you akan dapat RA1 equal to 2.4 minus 17. You akan dapat 1.33 kilonewton. So this direction definitely equal because there's no other direction. So this is 1.5. Okay, you done for the first plane. For the second plane, do it the same. So sigma A equal to 0. Kemudian you akan dapat, you kira 4. So both these 4 kilonewton moment at A, about A, so opposite direction with RB2. Okay. So 4 times 125 equal to, let's say, RB2. So 50 times plus 125, 175. So RB2 is equal to 4, 125, 175 equal to 2.86 kilonewton. Then RA2 equal to 4 minus 2.86. You akan dapat 1.14 kilonewton. And this A, this direction, is equal to 1.5, sama. So the axial load, the axial reaction at bearing A. So you get the value of you get the reaction force at the bearing A and B in the different plane. Okay, now we have done in question 1. Then draw the shear force, moment, and torque diagram. Okay, kita lukis balik. So you have reaction force here. This one plane, this another plane. The force acting here. Acceleration force. A, B. This is 1.5, 1.5, 1.33, 1.07, 1.14, and 2.86. Okay, shear force diagram 1.3. This 125, this is 50, 125, 50. 1.33. Get to this one. And this is 4 kilonewton. So 4. This is 133, it's 107. Then moment diagram, bending moment. So 1.33 times 125. So you will get this value is 1.33 times 125. So you will get 166.2 Newton meter, this value. And this value is the next from here, 1.07 times 50. Then you will get 53.5 Newton meter. So somewhere down below the 1.66. This is 53. Then you got the line. This is the value. 53.5 Newton meter. Okay, this is the value, 166.2. So this shear diagram, this moment diagram, bending moment. So for this one, 1.14 times 1.14 here, then okay, should 1.14, then this is 2.86. So for moment diagram, 1.14 times 125. 2.86 times 50. The same value. So this is 142.5 Newton meter. Okay. So for the torque, you ada kalau tengok torque yang you ada torque ialah this one lah. This is a torque. Kan? Torque yang ada, you ada 4 kilonewton times the radius. So just have torque here. This one. So this torque is 4 kilonewton. Radius is 0.075. So you get 300 Newton meter. Stop. So now you have identified that the critical point for the shaft is at gears, okay, located at the gears. So you see that here, this force, radial force, okay, causing the bending. This tangential force causes the torque, and this axial force, okay, axial force causes the axial load. Axial. So we have to consider those all three types of loadings on the gears. So then we should calculate the stresses, okay, the stresses acting on that shaft located at the gears. So we know that it has the axial loads, cause the axial forces. Okay, axial loads. That's one. The second one we have is by the radials, so we have bending loads. Then we have torque. Okay, we have torque, torsion, cause the torsion. Axials, bending, and torsion. So for the axial loads, so as we know that we have both, we're supposed to determine the alternating stress caused by axial loads, which is X, sigma, alternating caused by axial. Then we have to determine the means caused by axial. Same as bending, we have to determine the alternating. Either it has the stresses, alternating stresses or mean stresses. So this alternating, we have to calculate the alternating caused by bending. And this one as well means caused by bending. And this one as well, torque, tau. Okay. As we learned before, the alternating is the alternating. If reverse, this reverse. This is alternating sigma A. For the bending, sigma A. So alternating means, yeah. Okay. This is sigma means. So you have to look the definition of alternating stress or the mean stress or steady stress. So we looked at the axial loads. For the axial loads, this is axial loads. So it has no alternating, no frequency. Okay, it's not just a one direction. Same as the torque. Torque, there's no back and forward. But for the radial cause bending, so it has the frequency. Okay, it has the alternating stress. For the radial force, for the tangential force, cause the torsion where the shaft twisting. So, but there is no alternating shear stress here. Same as the axial loads. So there's no alternating stress. So here there's no alternating stress. This is 0. Bending, yes, it has the alternating. For the torsion, it has no alternating. Just means. Okay. So then we just calculate the sigma means caused by axial loads A. So which is cos axial divided by A. Okay, it has no mention on the diameter of the shaft. Okay, diameter of the shaft. The diameter of the shaft is, because we are looking at the shaft. So diameter of the shaft is 33 millimeter.
Doctor,
Yeah.
sorry, Doctor, I couldn't understand how to know that the force is alternating or not, the bending.
Okay. Okay, for the radials, for the radial force, okay, it same like we do R and R more. So where give and the loads is the weights. Okay. So it means that this is shaft and giving the loads. So it alternate. Okay, the force will rotate alternate. But for the radials, because radial force cause the bearing to rotate. Okay, bearing to rotate. But there is no alternating. Okay, by understanding that when rotation there is no, just the shaft, that's just the rotation of the gears which cause the shaft to rotate. So there's no alternating. Alternating mean it macam berayun lah, macam berayun. Tapi kalau dia pusing, kan, dia pusing, so just pusing. Doesn't the kalau dia pusing tu berayun, kan, something like it has not balance or something that rotation positive and negative.
Dia bounce
Positive
ke,
and
Doktor?
negative. Huh?
Maksudnya dia bounce ke, Doktor?
Sorry?
Bounce.
A bounce. Kalau bounce tu, yeah, kalau bending tu, it seem like bending is bounce. Bending is yes. For the radials, yes. Radial, yes. It's like macam, jadilah. Kalau radial, dia macam something like macam ni, dia naik atas balik. This is the radial. So it has alternating. That's alternating. Therefore, the graph of alternating macam ni. Alternating. So sebab tu kita kira, kita dapatkan, we have to determine this is this sigma A. The alternating stress. Okay. Untuk radial, it has, but in this gears, okay, in these gears, it has no alternating. There's no alternating. Same as for the axle. Definitely from the gears, there's no let's call it back and forward. Tak ada kan, ke depan ke belakang kan, tak ada. Tapi possible untuk the gears to apa panggil, atas ke bawah kan. Bending it has. See, therefore the R and R more exact test. So for the bending, looking for the fatigue of the material of the bendings. So nanti kita tengok macam mana kalau ada torque. Okay, for the torque, the alternating torque, shear alternating stress. Kita akan tengok soalan tu nanti. So for this condition, for the tangent force, there's no alternating. Axial force, there's no alternating. Only for radials. Cause force yang menyebabkan alternating stress due to bending. Okay, this D equal to 33. So kita boleh kira A, we could calculate for A, pi D squared. So we get 855.3. Then sigma means steady load. The load just steady loads. There's no alternating. Means for axials F axials divided by A. So you akan dapat this is 1.75 megapascals. Okay, untuk bending, it's like the RRN mode test. So dia akan jadi macam ni lah. Kita panggil reverse, fully reverse. Okay, fully reverse or completely reverse stress. Completely reverse stress. So it has the alternating, but means is in the middle. So mean is 0. Means is equal to 0. So sigma A for bending, alternating, equal to 32 moment times pi t. So what is the moment? So combination of the moment, kita ada so in the middles, so assume that we look that in the middle at the gears is the critical point. Different planes. So we have to consider both 166 and 142. 166 and 142. So total bending ialah 166.2 plus 142.5. So you need to convert. Sometimes you need to convert from. So because we want for easier for us to use a Newton millimeter. So just convert from meter to millimeter, then you get the value of 2189 to 6.2 Newton millimeter. Then insert this value to this. Then you will get sigma A bend alternating stress for the bending. You will get 62.05 megapascal. Okay, untuk torsion, we don't have alternating. So just has the steady load, shear load, steady shear stress. Okay, so for the mean shear stress, stock by so 16 torque 30, convert from Newton meter to Newton millimeter, so 300,000 divided by pi. So you will get 42.56 megapascals. Okay. So you have three values. For the axial loads, you have mean stress. For the bending, you have alternating stress. For the torsion, for the shear mean shear stress, torsion, you have mean shear stress. Okay, you have just three types of stresses. Then you need to combine. You need to combine means means combined with the means and alternating combined with alternating. Okay, for the combine, kita panggil apa? Equivalence. Equivalence alternating stress. So we use distortion energy theory. So sigma alternating bending squared plus tau alternating, and then equivalence means kita guna apa dia panggil sigma means axials divided by 2, then plus means plus sigma means axial divided by 2 squared. So equivalence alternating. So alternating for the alternating, we just have bending. For means, we have axial and torsion. So it means that alternating, this is 0. So this one we get 62.05 megapascals. Untuk means, equivalent means, kita ada this value and we have this value as well. Okay. For the axials means (1.75). Torque mean 42. 5 plus 1.75 square. Dan kita dapat 43 megapascal. Okay, so the exact value kan, the exact equation untuk equivalent alternating stress and same as equivalent for mean stress. So you will tengoklah dalam slide, the slide that I've given to you. You could see the slide that I've given to you. Okay. So kalau kita tengok next, if we see the ranges for the yielding is Langes. So Langes is one EA is saying plus means this is safety factor. For the fatigue, Goodman (1 over EA SN plus sigma EM divided by alternate strength. So we have yield strength, we have yield strength, we have equivalent alternating stress, we have equivalent mean stress, we have the value alternate, but we don't have this one. So we need to calculate this one. Endurance limit. So endurance limit Sn equal to Sn prime CL CG CS CT CR. Okay, so this Sn prime is for the steel 0.5 times ultimate strength. So 0.5 times ultimate strength is 900. So you could check later. So I have looked already the value of load factor, size factor, surface factor, temperature factors. So load factors 1, size factor 0.9, surface factor approximate 0.9, temperature factor, there's no mention of any temperature, just 1. Same as reliability factor, no mention any reliabilities, so just 1. So you get the value of 364.5 megapascal. Okay, so you get all the value for calculating the safety factor according to yielding, okay, failure and the fatigue failure using the Goodman. So when you insert all the value that we have calculated here, so then you will get for yielding lenses, you get 6.64. And for the Goodman is 4.6.
Doktor,
Yeah.
nak tanya, kenapa kita tak consider mean bending?
Oh, means bending sebab dia completely reverse stress.
Okay.
Okay, complete reverse stress, kita dapat graf ni. So means dia tengah-tengah zero. Means you tengok balik sekejap saya share. Okay, this alternating stress. Okay, alternating stress sigma A and mean stress. I'm calculating. Okay, mean stress sigma max plus sigma means divided by 2. Alternating sigma max minus sigma means divided by 2. So we have 3 different types of fatigue stress or fluctuating stress. Okay, one is that we the test for endurance limit, they use RR more testing. Okay, it is fully or completely reverse stress macam ni. It's the case of bending lah yang ada dibagi macam tadilah bagi radial force daripada atas tu, so dia menyebabkan shaft tu dia ada sedikit bending, berpusing. So this plus dan minus, plus minus. So then sigma max minus sigma min. Okay. Sigma max maximum minus sigma minimum. So you akan dapat sigma min equal to 0. 0 kat tengah. Kalau repeated stress, so sigma min you bukan 0 lah. You tak akan dapat sigma min bukan 0. So the criteria of repeated stress macam ni. So this fluctuating macam ni. So you akan dapat, you have the value of sigma min. Sigma min ni macam kita convert jadikan steady loads. Okay, dia dua. Satu, it has 2 types. One is alternating, fluctuate. Okay, dia akan fluctuate lah. So apakah value of that fluctuating? So that is alternating stress. Okay, so this alternating for upward and this alternating for downwards. So what's the value of that value from the middle line. Okay, the middle line of the sinusoidal graph. What is the middle line? From the middle line, that is alternating. Means the value, the middle, the means, kan? Nilai yang tengah tu, the means. Berapa nilai ni? This means. So this is the common, okay, types of stresses. Okay. So kalau tak ada alternating, just one single load. Okay, just one single load. So it means that just one from stress, kita akan just satu line je lah. Macam ni. Ini value dia. Okay. Single load, macam mean stress lah. Single load macam ni. Ini single load. Kalau kita bagi just one single load, there's no alternating. So this single load is like the mean stress. Okay, just single load. Mean stress. Okay, then we finish. So we have calculated the value of safety factor due against yieldings and then Goodman. So Goodman is fatigue because it consider the SN, endurance. Yielding against yields using the lenses. So therefore it just use the yield strength of the materials. Okay. So andai kata kalau kita withdraw the graph. So this is sigma means. This is sigma alternating. So kita ada SUT. So we have just below is yield strength. So kita ada sini pun yield strength. So di sini kita ada downward, kita ada endurance limits. This is the guarding line for yielding. So this is guarding line for fatigue. Okay. This yielding. So the value of the sigma alternating that we get is, okay, yield strength is 700. Ultimate is 900. And alternating is 62 and the mean is 43. So alternating is 62, alternating is 62. Somewhere here, let's say 62. So this is yield, this 364. This is 700. Alternating is 62. Let's see here. 62. And means is 43. 3. Good. So this is location of stresses experienced by the shaft. So when we plot the straight line, so sebenarnya kita boleh dapat the maximum one, the maximum due to okay, this is the Langes, this is the Goodman, the line of Goodman. Goodman is fatigue. This is Langes is yielding. This is the maximum where the component could fail. Okay, this is equal to 1. Okay, this is the maximum. And this is the maximum for Langes. Beyond this, it will fail due to Goodman, but beyond this will fail due to the Langes. If the point is here, fail due to Langes and Goodman. But if here, it will fail due to Goodman, fatigue, but still safe for Langes. So this is the point. This is sigma means value. This is sigma A value. Okay, so you will see that the people don't, you will see some graph, they don't continue the line of yield strength because of the space. Sometimes you just see this line. Okay. Okay, so this is the line of for yielding. So you will see the line like this. Okay, class. So for your assignments, just rewrite and understand for this question and submit. Okay. Ada soalan lagi? Ada soalan? Okay, kalau soalan kita buat soalan lain. We do another questions. Okay, due date. Khamis lah, Khamis. Thursday, boleh? Thursday. Nanti saya set kat e-learning. I will set in e-learning. Okay, next questions. Okay, for these questions, kita lihat it is shaft. Shaft. Diameter with 50 mm. So we focus on it has the fluctuating stresses, nominal stresses. Okay. Fluctuates up and down, fluctuating. Nominal, nominal stress. At the center of 50 millimeter. We are focusing on that 50 millimeter. So the materials ultimate strength equal to 600 megapascals and the yield strength is 400 megapascals. Okay, this is nominal stress, nominal stress. Okay, nominal stress, it could be bending, it could be torsion, it could be axial. So ada tiga kan? Kita ada tiga. Axial, bending, torque, torsion. Okay, nominal, okay, common lah. Dan nominal means the normal value. That's the void value. Okay. If, the first question, if nominal stress ni is, if this nominal stress is bending. Okay. So determine the kira pun dia tak pandai tulis dalam ni. Dia licin sikit. determine safety factor. Determine the safety factor to akhir sekali. Okay. Respect to fatigue failure. Kemudian next, the second question, if this nominal stress is torsion due to torque, same, determine safety factor for the fatigue. Okay, so fokus pada sini lah. 50. Okay, rough ideas. Bila nampak soalan macam ni, this problem, so the rough ideas. Apa kita nak buat? Okay, pertama kita akan, the first thing that we see that it has the discontinuities. And so maknanya kita, in our mind that we have to determine the highest stresses in which we have to determine the critical point. And also then we need to calculate the KF. Kan, KF. So kita ada kat sini 2 point lah, sini 1, sini 1. So this area kita kena kira KF. So nominal bendings, okay. Kemudian next KF. So we have identified the identify the critical point. Okay, identify critical point sama ada either you could compare, or if you see that this is the maximum, this the value is larger than this value, which is the critical one? Yang besar ke yang kecil? The smaller or the larger? The bigger one.
Smaller one, Doctor.
The smaller one. So from the value, kita could just look, okay? Or we could prove, but we just choose one. This is the critical one. So we choose this filler size, filler radius to calculate the KF. Then we plan, okay? When we see this problem, we plan, okay, what we are going to calculate. What we are going to calculate. So first we have to calculate fatigue Sn. Okay, Sn. Sn prime Cl Cg Cs Ct and Ci. So we get this value. The second one, Kf, okay, equal to 1 plus Kt minus 1. Okay, so we need to calculate the Kf. So this is the critical one. The third one, sigma means original sigma means, the original sigma means. Then sigma alternating. Mean stress and alternating stress. The original from this graph. After that, we calculate the real. Okay, the real is equal to Kf times sigma means that called 0 and sigma A Kf sigma A 0. Okay, kita ada this value. This value. Okay, then kita boleh kira lah. Then kita boleh, we could just insert the value, to this one. We have this value, this one, okay. Good man. We have this value because just one value, kan? Just one value. There's no combination of the value. There's no torsion, there's no others means, other bendings. If there is other bendings, so we need, or torsions combined, so we need to use the equivalence. This one. If there is other alternating stresses, so you have to combine. If not, just use that one. Because all the torsion is 0. This is 0. This is 0. And this value, if we don't have this value, just 0. Just this value. 0. We just have this value. We just have this value, just directly taken. Okay. Then finish. Safety factor. Okay. If the question is using the graph, if the question using the graph, how to calculate the safety factor? So if the question is the graph, so we have calculate, we have the value here. Okay, we have the alternating this value. From this value, just make one line, touch the value of Sn, touch the value of this one. Then you will get this value, the maximum. So this value divided by this value. This is what we call it nampak overload. Okay. Overload. Causing eventual failure. Okay, this value. Eventual failure. Just border. Okay, just border. The maximum eventual failure. So this value, let's say x y1 is to y2. So safety factor is equal to y1 using the graph. Otherwise, just using the formula, you will get the safety factor. So if torsion, if this is torsion, okay, if this is torsion, it means that you have shear stress. You have shear stress here. So the same thing that you have to calculate this one, but it has different loading, right? The value is depending on the loading, bending, axial, and torsion. So you have to be careful taking the value. So you have to take the value from from the torsions. Okay. Same as the KT. Okay. Same as the KT. So for one, okay. Kejap. Okay. So for the first one, Sn equal to Sn Cl and so on. So you have to be careful of taking on the torsion. So for the Kf equal to 1 plus Q Kt minus 1. So Kt and Q, be careful taking from the graph of torsion. Okay. Then you calculate the mean shear stress. So then you calculate get the value of mean shear stress and alternative shear stress, then times the real, this is O, so this Tm equal to Tmo times Kf. Because there's no means, there's no bending, just focus on torsion. Okay, just focus on torsion. Same as this AO equal to AO times Kf. So the same value that you get, the same procedure, same method, way that you have using for torsion and bending. Because they just focus on torsion. If it has torsion, shear stress, and bending stress, if you have this one and this one, okay, so you have to calculate for using equivalence. Okay, using equivalent. If there is no just one, just focus on one. There's no need to use the equivalent. Faham So kalau ada dua-dua value ni, ada satu bending stress, satu shear stress. So you kena gunalah this equivalent ni, value untuk combinekan dia. Kalau just satu saja, just fokus pada satu lah. Ni value, di value ni, ataupun value this one, atau value this one. Okay. Boleh faham? Ada soalan? So kalau torsion, shear stress, so the graph, this is for bending. Kalau torsion, only torsion. So just change this A. This dominance. Kalau lukis graph, so just tukar this one. Sama juga. Okay, so I think we have done different type of questions. Satu kita dah the first question kita buat apa? Apa? Okay, first question kita ada simple completely reverse bending. Completely reverse bending. Kita ada this type of question. Okay. Just so this one we just have this like this. So fully reverse bending. Ini kan? Soalan kedua, then kita ada this one, fillet KF. So you have to calculate the KF. How to use the graph. The second question that we discussed today is different types of loading. So we have tangential. So we have FR, radial forces. Then we have tangential forces, okay, causing the torsion of the shaft. Then we have F axials. Okay, so from here we have different type of stresses. Kita akan dapat bending stress. This one ada sigma alternating and sigma mean stress. Then we have torsional stress. So we have alternating and means. Then we have axials. Load. Ni pun kita ada sigma alternating caused by axial loads. Sigma means. Okay. This bending, this is a bending. Okay, if we have two bending, so if we have more than if we have more moment by today discussion, moment 1 and moment 2, so we have to combine moment total equal to m1 plus squared m2. This is a total moment total, normal moment total. Okay. So we use this one to get the value of bending stress. If we have different sigma A, tau A, then we need to combine. So we need to combine using equivalence, EA, and equivalent for means. For the alternating stress, kita gunakan distortion energy theory. Yang kita ada sigma axial, this one axial plus sigma. Bending, this is from the axial, this from the bending. So divided, squared, not divided, power of 2 squared. Plus alternating this one, this alternating, 3 alternating. This means. For the sigma means, kita gunakan maximum principal stresses. Kita combine this means and this means and then this means. Kita combinekan 3. Ni, this one. Sama juga kita combinekan ini, kita combinekan ni. So kita gunakan formula sigma means axial plus sigma means bending divided by 2 plus tau means squared plus sigma means axial plus sigma means bending divided by 2 squared. Okay. Okay, then you could proceed calculate the safety factor. Because kita dah kira ni dah. Kita dah kira SN. Okay, kita kira SN. Okay. So I hope that you could get the overview how to use all the equation. Simple equation actually. Macam mana kita nak using cara step by step. Okay kelas, ada soalan? So it's next question, saya rasa yang ni lah simple. Nanti saya bagi soalan lain satu lagi. I give another question for assignment. Simple questions. Just direct reverse bending. Reverse bend, different situation, different problem. Okay kelas, ada soalan? Any questions? Fatigue? Okay,
Doktor,
yeah.
bila masa kita nak guna untuk yang KTKF dan bila masa kita akan just
Oh, KF kalau ada kat sini, kalau problem kita kalau ada shaft lah, different size of shaft in one shaft. Kalau shaft tu just straight shaft, no need to use KF.
so mainly look for fillet lah doktor. Kalau untuk KT ni.
KF pun definition of KF pun okay, definition of KF pun nama dia KF tu ialah factor, amplification factor to the fatigue stress. Kita dah ada fatigue stress. We have our fatigue stress. Fatigue stress ni okay, we have determined the fatigue stress. This one. Okay. Kemudian, then in our problem, it has the fillet, different size. In one shaft, definitely, normally the shaft, it has no one type of shaft. Normally, on the shaft, should be sometimes holes, sometimes waist untuk letakkan pin. Okay, and then when you insert the bearing, so the size, the inner size of the bearing, the inner diameter of the bearing should be different from the size of the shaft. Kan? Mesti beza punya. There's no, normally there's no one size of the shaft. In the real situation, there's no one size of the shaft. Okay, what's on the shaft? Okay, normally shaft, we have gears. Then we have bearing. Then how to fix the gears? We have pin ataupun kita panggil apa, waist. Kita akan tebuk lubang, then squat, and then put a pin. So that is the stress concentration. And also when we put have bearing both sides of the shaft, so then that diameter of the shaft normally is larger than the diameter of the use diameter of the shaft. The diameter shaft yang kita gunakan tu biasanya shaft yang diletakkan untuk bearing, okay, normally a bit larger. So it has the fillet, okay. So when it has fillet macam ni, bila ada fillet, so dia ada stress concentration. If there is a hole, it has the stress concentration. So when it has stress concentration, so we will use amplification factor. So this amplification factor is Kf. If the problem no mention any or the pictures, the shaft, there's no discontinuities, stress concentration. So you no need to use Kf. Okay, so nama pun fatigue stress concentration factor. From the existence of irregularities or discontinuities in materials. Okay. Dia ada perbezaan saiz yang menyebabkan stres tu akan terganggu. Stres normally kalau you tengok stress flow is the straight line. No. So kalau ada discontinuities or irregularities, so that point will be the place for stress to focus on. So the stress will like assemble, gathered in that particular area. So waktu kita kena, dia akan menjadi, stress tu akan jadi besar. Sebab tu kita panggil amplification factor. So dia akan jadi besar lah bila kita darab dengan Kf. Okay, ada lagi soalan? But be careful, use the value. Okay, Q value kena ada bending, axial, torsion, sama juga dengan same as this one. Bending, torsion, bending, torsion, different graph. And the one is this one. This one sama. This one. Okay. KL, CL, CG. Okay. So it has different value if you use bending, axial, and torsion. Okay, kelas, ada soalan lagi? Any question? Kalau tak ada soalan, okay. And next week, we will move to the new topic, gears. Okay, just to remind you that after Hari Raya, so during the Hari Raya holiday, so you cannot eat too much ketupat. Ketupat, kuih-kuih. Sebab after Hari Raya, you have test. So after Hari Raya, you have test. According to the schedules, the first week after, immediately after Hari Raya. So you have test 1. So test 1 will cover static, fatigue, and gears. Just 3 topic covers. Kemudian, so in my class, I think we have 29 students. Okay. Okay. So we have 29 students. Ada 10.45 baru slide ini. Muhammad Afiq Irfan. Baru bangun tidur terus slide in. So, could you form a group of 3? Form a group of 3. 3 times 721, 3 times 8, 7, 21, 8, 24, 9, 27. Okay, 3 form the group of 3. Because we will discuss your major project. Your major project. Only 2 groups. Only 2 groups will have 4. The rest will have 3 members. Okay. So total we will have 7 groups. Okay? 9 groups. 9 groups. Total we should have 9 groups. Next week and over next week. Okay, next week and over next week, we will discuss the major project. Before you go back to for holiday break untuk Hari Raya, sambut Hari Raya. So kita akan discuss on the major project. So you could bring something, okay, for your major project. Actually, the major project already started. Should be started earlier. Ada soalan kelas? Kalau tak ada soalan, kita end the class. Kita dismiss class for today. Alright, thank you.
Thank you, Doctor.
Thank you, Doctor.
Yeah.